Hello and welcome to lesson 2 of week 25. In this lesson, we are going to look at how to create the model for our class project. We are going to build upon what we did in the last lesson, and the first thing we want to do is create a client profile where we can have a unique ID and all of the client's personal information. So we want this to first of all be the entry point to all of the client's data. So this table is going to hold information that include account creation information for a client. So when we create an account for a new client, this table will be populated. And then when we start inserting records for that client, we now begin to have that record on other tables, but the unique ID from this client profile table will now become the foreign key that links all of the records together. In week 23, we use declarative mapping to create our tables in the model file. We are going to continue using that, and for this lesson I have deleted the person table that we created, and I have modified the app file to fit what we are going to do for this lesson. We are going to create a new database called STI data, and I have changed the database name in advance. We are going to have several models, several classes, and so I changed the import statement to import all from the models file. And then because I'm importing all, I just want to create all of the table at once. So instead of listing person and create table one after the other, I can just use base.metadata.createAll engine. So I did this in advance, so I'm showing you now so you can know exactly how to change your app file to be able to run the models that we are going to create. In my SQL workbench, I'm going to start my SQL workbench, and I'm going to create a new schema, and this is going to be called STI data. My default character set is UTF-8 MB4, and the collision is Unicode CI. And then I'll apply and apply. So now I have that already created here. So this is the database where we want to create all of our tables. So now let's start. So just to refresh, we first constructed a base class using the declarative base, and then when we subclass the constructed base class, the declarative mapping process now applied to all the subclasses that derive from it, and this is relative to a particular registry local to a new base by default. Now, because this is not an SQLAlchemy course, I'm going to leave links to further readings for you, but I'm going to just tell you as much as I can for the purpose of understanding this lesson. In this file, I have already imported all that we will need. We will need integer type, string, foreign key, date time, and then we need func, and we need this just for us to be able to insert a default date time when we have a date column that we need to insert automatically. Then we also need to have mapped declarative base like we always have, and then I imported datetime for Python, and then from typing imported optional so that we can have optional fields that are not required. So I want to create a first model, and this model is going to be called the client profile. And again, this is going to be inheriting from base and base model. The table name we want is going to be client profile, so we use table name client profile. We want to have an ID that is an integer column, and it is the primary key. So say map int mapped column integer primary key true. We want to have a created at column so that whenever a new record is inserted, we have it created at. So this is going to be a mapped column of date time, and we want the insert default to be now. So let me use insert default. So read up further on this, but this is the structure. We also want to have an updated column so that whenever the record is updated, it inserts the timestamp of the last update. So say insert update, and I'm going to remove this. Then we want to have a created by and an updated by column. So let's say created by, and it's created by somebody. We want to have that to be a string of 100. In the event we have encryption, we need more space, and then we want to insert default, let's say system. So we want to be able to insert the username of the person who is logged in and filling in the form. Updated by, the same thing. So we want to have the unique ID first, which is the entry point. So we'll say unique ID is equal to map string, and we want the unique ID to be unique. So let's say unique equal to true. We want to have the first name column, we want to have the middle name column, and we want the middle name to be optional. So if you want something to be optional, that's when we'll use mapped, and then here we'll put optional string. So this way it allows null values there. We want to have a last name column. We also want to have a date of birth column. We want to have a country of birth column. We want to have a gender column. So you can actually research how to use enums when you want to have predefined values of the list of genders, or you want to have things like yes or no, and you want the values to be defined. So I'll leave that to you to research how to use enums here. We want to have a column called marital status. We want to have gender identity. Let's just accept this, gender identity. We want to have phone number. Let's have sexual orientation, phone number. Let's have address. Let's say the address is longer than 100, or because this is just for illustration, we can leave it as short as this. But when you are creating your models for real world use or for production use, you have to specify the column length and the correct data type, so that you don't run into problems when the length of the data collected is more than the space that you have allocated for that column. So the address, we can make it an optional also. We can make the phone number optional also. And let's say we have city, state, zip code. Then let's say we have the country too. We have an email address. We want to have ethnicity. We want to have race. We want to have, I think let's just stop here since we already have a lot of data. So these are the columns that we are defining for the client profile table. We have this unique ID column, which is going to be a foreign key on other tables. We have looked at in detail how we use integer string, how we use this declarative mapping in week 23, and we did not use the date time, but now we use date time. We insert default func.now. We want this to be a timestamp inserted as the current timestamp and when a user enters data, and then we also want the unique ID column to be unique. Now that we've done this, let's create other tables that will hold information across this. For us to save time, I'm going to copy what I've already done before, and then we are going to walk through it. Okay, now so we have more tables that I just pasted because typing them out will waste or will prolong this lesson. We have a new table called client screening. Now this table is going to collect information about the screenings for the clients. We want the unique ID now to be the entry point or the identity for us to know whose record are on this row. This is a foreign key, and we define it by using this foreign key constraint and now providing the name of the table and the column that is a parent for this. And I specified on update cascade, on delete cascade, so that whenever the parent is updated, we want the children to be updated. Whenever the parent no longer exists, the children should no longer exist. And then all other column definitions are exactly the same structure that you've learned from week 23. We have another table called client treatment, and it takes the same structure. Having the unique ID has a foreign key from the parent table. Partner management also, we have a unique ID for the partner, and then we have partner unique ID, which references the unique ID of the person who is originally screened, who listed this partner as a sexual partner, and so we have that one as a foreign key. We want to cascade on updates and on delete also. And so we have all of these tables defined. Refer to your course resource for the full code that we used, or for you to be able to follow on with this code. And I'll also leave links to further readings in your course resource for you to be able to look in details at declarative mappings and the typing and all of the definitions. So now that we've done this, we want to go back to our app file, and because we've already specified the name of the database that we are going to be connecting to, we have already said that we want to import everything from the models, and then we just use base.metadata.create all engine. If we don't do this, we can do something like client screening. We'll still need the base. We have partner management, and then we have something like client treatment. And then here, instead of doing this, we can use this, or we can just say client profile dot table dot create engine check first equal to true. So we can just do engine or bind equal to engine, and then we do the same thing for the next one for client screening. So you see, this is hectic to list them one after the other, so it's easier to just do base, import all, and then use the base. or if you don't even do that with all the imports. So since we need everything on it, we just import all like this. So I'm just showing you the different ways we can do this. So we'll use import all, and then I'm going to comment this out. So let's run this app file by clicking on the run button. We know how to start a Flask app here if you want to start it from your command line, or I click run. If all is well, we should be able to refresh here to see that our SCI data now holds tables, and all of the tables are connected like we want them to be. Now this is the modern way of using SQLAlchemy, but this is not the complete definition of all the constraints. So you need further readings to be able to know everything that exists when you need them and how to use them, because when you start creating other forms, there will be more use cases that we have not covered, and that is where your further reading comes in. But this gives you a head start to know basically how to create your tables, how to create relationship between tables and enforce constraints on tables. And so we're going to run the app file, and if all is well, we should have the development server started and all of the tables created. Good. Now everything is well, we have no errors, we have the debugger pin, we have this, and so let's follow the link. Hello world is correct, so go to the SQL workbench, we refresh, we have all our tables that we've created, it's working fine. Let's go to client profile and let's look at the foreign keys. This is the parent table. We can look at the column, all defined, and then we want to look at the client screening, look at where the foreign keys are and see what it is. So we have a foreign key of unique ID, and then on update cascade, on delete cascade, and it's from the client profile. So all our tables are connected like we want them to be connected, and everything is looking well. So this is where we end this lesson. In the next lesson, we're going to go further at looking at how to use this whole structure to insert record into the table, and then we're going to continue creating the forms and seeing how we can now do a front end to collect data and process this data and send into the database tables that we have just created. So thank you, and see you in the next lesson.